Welcome back, class, to another physics lesson. Today we're going to look at part 2 of magnetism, and today we're going to look at this phenomenon called magnetic induction. So, what is magnetic induction? Magnetic induction explains why magnetic materials like iron and steel are attracted to magnets. So let's say you have iron nails and they behave normally, and this is the iron nails without magnets nearby. And then when you bring close a magnet to these iron nails, you can see the iron nails are instantly attracted to the magnet. Why does this happen? So when a magnet is brought close, it induces, so there's this new word here. To induce means to influence or give something a certain property. So in this case, the magnet induces magnetism in the iron nail. So the magnet lends its magnetism to the iron nail. So the nails become temporary magnets and then are attracted. So how does this happen? So let me just repeat that again. So when you bring close the magnet will lend or induce its magnetism to the iron nails. So the iron nails become temporary magnets. That means they have poles, but only temporarily. So for the first iron nail here, the top part will become the south pole, the bottom part will become the north pole, and same thing for the iron nail at the bottom. And this will be arranged in a way that there will be attraction. So you can see north will be attracted to the south, and this end of the north pole would be attracted to the south end of the other nail. And so that's why they are attracted. But once you remove the magnet, so the magnet is far away, the nails loses its magnetism. So it's no longer being induced by the magnet and returns back to normal, so it doesn't get attracted anymore. So this is magnetic induction. So magnetic induction is a process where magnetism is induced in magnetic materials. So it's where magnets lends or influences the magnetic materials to have magnetism, but they only become temporary magnets. So this effect is only temporary. It only happens when the magnet is near the magnetic object. When it happens, the object becomes what we call an induced magnet. So an induced magnet is basically just a temporary magnet. Magnetic induction can also occur without any contact with the magnet. For example, here, let's say you have a magnet being brought close to an iron bar. So this magnet will induce this iron bar. It will give this iron bar or lend this iron bar its magnetism. Okay, that's one way to think about it. So this iron bar becomes a temporary magnet or becomes an induced magnet. So the iron bar will have poles. So the south side will be there, the north side will be there. So the position of these poles will be in such a way that there will be attraction between the magnet and iron bar. And then once that happens, they are both attracted to each other. So this phenomenon happens very quickly. So in our eyes, it happens instantaneously, but in nature, if you slow it down, magnetic induction happens first, and then there's attraction. So there are steps before the iron bar becomes attracted to the magnet. Now let's look at the bottom example here. In this case, the iron bar becomes an induced magnet and it will create poles like this. So the north of the magnet is closer to this point. So this point becomes south, and then this end here becomes north, and then this ends here become the north pole. Okay, so that is what it looks like. All right, so let's answer a couple of questions just to help you understand what is induced magnetism. So this is the sort of question you will encounter when you do your O-level exam. So the question reads, in an experiment with a bar magnet, a piece of wood is held between the north pole of a magnet and two ions. Draw the induced magnetism within the two nails. So let's write down the poles for the two nails. So remember, the two nails are close to the magnet. They become induced. The magnet induced magnetism into these two nails. So these two nails become temporary magnets. And we have to write down what are the poles for these two nails. We see that the North Pole is closer to the two nails. So that must mean if there is attraction to happen, this end must be the South Pole and this end must be the North Pole. This end must be the South Pole also, and then this is the North Pole. Number two, although wood is a non-magnetic material, the two nails are attracted when the wood is held between the magnet and the nails. Suggest a reason for this. So even though the wood is between the nails and the magnet, the attraction still happens. The magnet is still able to induce magnetism in the two nails. So the reason why is because the nails become induced even without touching the magnet. So let's answer question 3. It is observed that the pointed tips of the iron nails point away from each other. Why is this so? So if you can see, this end here and this end here, they are pointing away from each other. What is the reason? It's because they are both north poles. So the pointed ends have similar poles. They both have north poles, and if the poles are similar, they repel each other. This next part, we're going to talk about something different. We're going to talk about theory of magnetism. So where does magnetism come from for magnets? So if we take a bar magnet and cut it into 3 smaller pieces, will the magnet lose its magnetism? Can we have a magnet that only has one pole? So here's the magnet. You cut it into 3 pieces. What's going to happen is that you have 3 smaller magnets. So the broken pieces of the magnet will each have their own north and south poles, so they become mini magnets. So the difference between a magnet and a non-magnet is that within magnetic materials, there are very tiny magnets called domains. So in non-magnets, the domain points in random direction, while in magnets, they are aligned in one direction. So the molecular structure or the atomic structure of the material determines the magnetism of the material. And each, atom has its own magnetism, if you like to put it simply. And if they're all aligned in one direction, then the whole substance will become a magnet. So for example here, this arrow represents the magnetism for that part of the structure. So this is north and south, and for this one, this is north and south, and so on and so forth. Okay, if they are in random direction, that substance won't be a magnet. It'll just be a normal object. But for some substances, their domains, as we call it here, are all in one direction. And when that happens, that substance has magnetism and is a magnet. All right, so for part 2, what should you know for your exam? So this is a summary. So you need to know what is magnetic induction. So magnetic induction is a phenomenon that happens because of magnets. And this phenomenon explains why magnets are able to attract magnetic materials like iron and steel. So basically, when a magnet is close to a magnetic material, the magnet induces magnetism or gives or lends its magnetism to the magnetic material so that they are able to attract. But once the magnet is gone or away, then nothing will induce the magnetic material, the iron or the steel. They behave normally. And then for your exam, make sure you are able to label where is the north and south pole for the induced object. For example, for this iron bar here, in order for it to be an induced magnet, the south pole has to be with the north pole, and then the other end will be the other pole, which is the north pole. Same thing here. Okay, make sure you are able to label the poles for the induced magnet or induced material. And that's pretty much it for this video lesson. The next part, we're going to look at magnetization and demagnetization, which are methods to produce magnets and methods to remove magnetism.